Hello everyone, this is Dr. Nimish Kumar Srivastava, Assistant Professor in Kumar Engineering College in Electronics and Communication Engineering branch. So in this module or lecture series of optical communications, we are dealing with each and every unit one by one. We got the basic concept about what is optical communications, how we can form the optical communication link with the help of various modules, with the help of various equipments that we can connect. After this, we have gone through the basic phenomena that is related to the optical communications, that is the total internal reflection, what is critical angle, what is V number, and as well as what are the different types of optical fiber possible. So in the second unit, we discuss about what are the basic phenomena that degrades the performance of the optical communications. So in that, we have studied about the dispersion and noise dispersions as well as the attenuations. We got through what is the meaning of a dispersion, what is attenuations. Apart from that, we have discussed what are the types of attenuation, possible types of attenuations, what are the phenomena that leads to a degradation in the strength of the optical signal. So we got through we have discussed each and every phenomena, and then we have discussed what are the different types of dispersion, that is the intermodal dispersion and intramodal dispersions optical fiber in optical fiber. So which type of dispersions mostly predominate in the single mode fiber as well as which predominate in the multi-mode fiber. We have discussed each and everything in details, and apart from that, we have discussed what is the meaning of a polarization mode dispersions and what is beat length and how we can formalize the thing, all these concepts in terms of a formula, which with the help of which we can find the dispersion, that means intermodal dispersions. Meanwhile, we have discussed in the unit 3 what are the different types of sources. So types of sources, we have discussed about the LEDs as well as lasers. Before discussing about that, we have discussed what are the materials that with the help of which we can form the sources, that is diode band gap material, in-diode band gap materials, and we have discussed why we are mostly using diode band gap semiconductors or materials for fabricating the sources. So that was a step-by-step foundation about what the typical topics related to the lasers. So we have discussed various phenomena, that is spontaneous emission, before that absorption, and then we have discussed about the stimulated emissions. So spontaneous emission, we all know that spontaneous emission is the basic phenomena which is responsible for the working of the LED. And apart from that, we have discussed what is double heterojunction LED, what is the advantages of double heterojunction LED, basically for the carrier confinement in that depletion regions for which we are fabricating the double heterojunction LEDs. Then we have discussed the lasers. What is laser? What is the meaning of this laser? What is the material that is used? And apart from that, which is the phenomena which is mainly responsible for the working of your laser. So step by step, what are the different phenomena with the help of which one can just have the lasing action. First one was we know that the first phenomena, the first process is is known as the population inversion. Then the second process is the stimulated emission, and the last one is the positive feedback. And this is positive feedback, that the third process is the mainly responsible for enhancing the number of photons in that cavity, optical cavity of the laser diode. So after that, we have discussed what are the different types of a laser diode. Before that, we have just got the basic overview about what is the advantages of a laser over the LEDs, and a laser, which type of source is mainly used for the efficient coupling of light in the single mode fiber. Then we have discussed about the what are the different types of lasers. We have discussed the Fabry-Perot laser, we have discussed distributed feedback laser, and finally we have discussed the vertical cavity surface emitting laser diode. So all these things we have discussed, and apart from these things, we have discussed the advantages of each and every laser diode. Then finally we move to the third unit, which is the fourth unit, rather the better word is, and the thing that we have discussed is about the detection. Once we have discussed what are the different sources that we can use, now the next thing is that we should get some basic concept about what are the different detection or detectors that we can use for converting back this optical signal into its equivalent electrical signal. So we have discussed what is the basic phenomena of a photodetector, whether we are biasing the whether we are biasing the diode in the reverse biasing mode, or we are biasing the diode in the forward biasing mode. Why we are just focusing mainly on the depletion region in the case of a detection process. Why we are enhancing the width of the depletion region of the detection? So that more and more number of photons that fall on that depletion regions, and apart from that, photon absorption leads to a creation of the electron hole pair. Now these charges can be easily just swept apart from each other with in the presence of this reverse biasing. So the more is the width of your the depletion region, more will be the photon that going to incident on the depletion region. As a result of that, more will be the number of a charge carrier that will be generated, and these charge carrier will be swept apart in the presence of the reverse biasing, which leads to a flow of a current. So that is the basic phenomena which leads to a conversion of optical signal back into the electrical signal. Now we have discussed what is the need of introducing an intrinsic layer in the pin diode, and apart from that we have discussed what is avalanche photodetector, which process is basically responsible for enhancing the number of photons. Apart from that, what is the impact ionization? We have discussed what is the multiplication factor, what is the formula related to the multiplication factor in the case of avalanche photodiode. And then finally we have discussed about the what is the detection process, that means the receiver that we can use. So now the thing is that we should know what is the basic block diagram of the optical receiver, what are the basic components that when combined they leads to a formation of the optical receiver. So everyone knows optical receiver must be having a optical detector. So because very first thing that one have to do at the receiver side is to convert this optical signal back to the electrical signal. Now once you have converted back this optical signal into an electrical signal, now the thing is that there might be a possibility that some noise have distorted your original signal. So we have to, at some step we have to amplify the signal, as well as we have to do the equalization process so that we can recover back our original signal. So that equalization process also involves some complex circuitry in which we must be having a threshold circuit, and apart from that there must be some filters that will be feedback, that the output signals must be fed back to the input so that it can be compared and we can generate the original signal back. So these are the basic modules related to the optical receiver. Now we will move into details about the optical receiver. Now before going ahead, we should know what are the different possible signal path that through an optical data link that is possible. So suppose that we are having the first one, that we are having a transmitter in which we are having a LED or a laser. So the both of the things can be used, as we know that LED and or the laser can be used as a source for emitting the optical signal. So either of these things can be used. So first is that we know that what is the information that we have to transfer. So we have implemented, we have given this electrical informations, we have given the information in the form of electrical pulses to the laser, this one. So the electrical impulses is given as an input to the LED or the lasers, and this laser will convert back this this electrical signal into an optical signals, and we will get this optical signals, and having this optical signal must be representing a series of zeros or ones, and each bit is having its own time period. So that is called as a bit durations, that is a bit period, which is the better word is bit period, and given by a symbol TB. So that is the bit durations, and this bit the series of bits in the form of optical pulses is passed on through the optical fiber. So this optical fiber carrying optical signals, so there is a possibility that these optical signals can be distorted. Now there is various phenomena which is responsible for the distortion of this optical signals. We have already gone through those, so there is no need to go into details about those things again and again. That will be a totally wastage of a time. So the thing is that because of various phenomena, whether it is intrinsic or extrinsic, there leads to a degradation in the strength of the optical signal. So that is the thing, that is the output that we will get from the optical fiber, some attenuated version of the original optical pulse that is being transmitted at the source end. Now this optical pulse, when given to a photodetector, that photodetections can be of photodetector will be of two types. Two major photodetector that are widely used is the pin, either pin or avalanche photodiode. So either of these things, these two photodetector can be used for converting back our original optical signal back into the electrical signals. So by this, at this time, at this portion, we are getting the electrical signal. So this electrical signal or electrical current pulses containing photodetector noise also. There might be a possibility that some noise might be introduced by this photodetector. So this noise must have affected the electrical signals, the equivalent version of the optical that means electrical signals, which is the equivalent form of a current related to the number of photons that is incidenting on the photodetector. So this thing is getting is fed as an input to the another modules, which consist of an amplifier as well as the filter. Now after this, we will get the voltage pulse and the amplified noise signal also, because amplifier will just amplify whatever the thing that is fed as an input to it, whether it is a signal or whether it is a noise. So even if there is a noise present in the signal, so apart from the original signal, so that original signal also strength also get amplified, as well as that the noise strength will also get amplified. So we are getting the amplified version of the signal as well as the amplified version of our original optical pulses in the form of a voltage. Now this thing is applied to the another set of circuit, which is known as the regenerators, or a decision circuit as well as the pulse regenerators. So now why we are using decision circuit? So that at the receiving side, whenever we are getting the amplified version of the signal as well as the noise, so if the signal strength is above some threshold voltage that we are just standardizing. Suppose that I am standardizing the things that if any voltage is above the 0.5, I will treat it as a logic high. If any voltage below the 0.5, I will treat it as a logic low. So that's why we have some threshold circuit that will help this receiver circuit to make a decision whether that whether that bit which has been received at the receiver side is to be assumed as a logic 1 or is to be assumed as a logic 0. So that is the thing which is that is the part which is done by the decision circuit. Now apart from the decision circuit, there is another part which is involved in this, is the pulse regenerator. Now this pulse regenerator will regenerate the original signal back. Whatever the signal that we are transmitting before giving whatever the signals in the form of the better word is the information in the form of electrical pulses that we want to transmit, that is our original signal, and we have converted that signal into optical, and then we did all those things optical domain part. Now at this side, this regenerator will regenerate back that original electrical signal, its strength, or we can say that it generates the replica of the original signal. So that is the main function of this regenerators. So at the output, we are getting a regenerated output voltage pulses. Now this output signal is applied to the signal processing device. This signal processing device will do its processing purpose, will do some processing, and it will generates the perfect version of the original signal. Will do all the processing, and even if we want to even if we want to do some calculations, we want to do some detection part, error detection part, correction part, so we can do all those things at this receiver portion, that means processing equipments. So all the information can be processed at this part. So that is the basic the different paths, signal paths that is going through an optical data link. So these are all things that one can easily write it down in the form of diagrams. So the next thing is that once we got this all the process that is going on into the optical channel, into the electrical domain, now the next thing is that we should know what are the main blocks that when combined they are forming a optical receiver. So the receiver, this receiver has the task of first converting the optical energy emerging from the end of a fiber into an electrical signal, and then it amplifies this signal to a level that is large enough so that it can be processed by the electronics following the receiver amplifier. Now this is the basic sections of an optical receiver. So this all the circuit which we are seeing at this present time, this constitute an basic optical receiver circuit diagram. So suppose that you are getting this question in your semester, or even if you are in your pre-university test, that explain optical receiver with the proper block diagram, then one need to draw this block diagram. Apart from that, you can also go through that the first block diagram that we have discussed in the previous slide, but that is less important in comparison to this portion. This block diagram clearly signifies that what are the importance modules that is responsible for detecting or getting back your original electrical signal from the optical version which has been passed through the optical fiber, right. So the thing is, the first process that is happening is we are incidenting our optical signal, because whenever we are generating the optical signal of the information, that is optical equivalent of information that we are supposed to pass through the optical fiber, that optical version is first fall on the photodetector, that is the depletion width of the photodetector, so that photons can be converted back into the charge carriers, equivalent electron hole pairs, which constitute a photocurrent. So this is the very first process, that optical signal have to fall on to the this optical photodetector, and then it is passed through a front end amplifier. So the optical signal that is coupled from the light source, right, that's coupled from the light source to the fiber, becomes it gets attenuated and distorted as it propagate along the fiber waveguide. Now upon arriving, when it arrive at the end of the fiber, a receiver convert this optical signal back to the electrical version. Now this figure shows that the basic component of an optical receiver, now the first element is either a pin or an avalanche photodiode, which we have discussed in the very first slide of the what is the signal, optical signal that is signal path through the optical fiber. In that we have also discussed the detection process, in which we are involving two main modules, which is a pin photodetector or avalanche photodetector. So that is the thing which this point is mentioning, that is the first element is either a pin or avalanche photodiode, which will produce the electrical current that is proportional to the received power level, which will be proportional to the received power level. Now since the electrical current typically is very weak, so that's why we are using we need an amplifier, and that's why we are using a front end amplifier to boost the energy or to boost the strength of this low signal or a weak signal. So that's why we are using after photodetector, the very first block diagram that we have seen is the front end amplifier to increase the strength of the weak signal. Now after the electrical signal produced by the photodiode is amplified, it passed through a low pass filter, this one. This filter is low pass filter, in order to reduce the noise that is outside of the signal bandwidth. This filter thus defines the receiver bandwidth. Now apart from this, in addition to minimize the effect of a intersymbol interference, the filter can also reshape the pulses that have become distorted as they travel through the optical fiber. So apart from minimizing the intersymbol interference, this filter purpose is also to reshape the original signals that is distorted because of various attenuation. Now, so this is the function of this function is called as the equalization, because it equalizes or cancels pulse spreading effect. That's why this entire process is called as a equalization process. Now in the final optical receiver module, a sampling and a decision circuit is also used in this diagram. Sampling and decision circuit, this final portion of this receiver module. Now what is the purpose of this? Its circuit samples the signal level at the midpoint of each time slot and compares it with a certain reference voltage, which is known as the threshold voltage, which we have already discussed. Why we are using a threshold voltage? So that whenever receiver have to make some decision to whether to the received bit is should come under the logic high or logic low, what is that decision factor, what is the decision level, what is the threshold level above which the receiver have to treat it as a logic low or logic high. So if the received signal level is greater than the threshold level, one is said to have received, and if it is below that threshold, we say that a 0 has been received. Now, in order to accomplish this bit interpretation, the receiver must know where the bit boundaries are. Now, this is making a decision or interpreting where the bit boundaries are. It is something done with the assistance of a periodic waveform which is called as a clock, which has a periodicity equal to the bit interval. Thus, the function is called as the clock recovery or a timing recovery. So, in some cases, an optical preamplifier is placed just ahead of the photodetector in order to boost up the optical signal level before photodetection can take place. Now, this is done so that the signal to noise ratio degradation caused by the thermal noise in the receiver electronics can be suppressed. Now, compared with the front end devices such as avalanche photodiodes or optical heterodyne detector, an optical preamplifier provides a large gain factor as well as the broader bandwidth. So, this is all about the optical receiver portions, that is that one have to draw what are the various block diagrams which together they can form a optical receiver. So, the very first is optical detector, that will be your pin or avalanche photodetector. Next thing is front end amplifier. This front end amplifier is used to increase or boost up the low level of the original signals. I mean, if the signal has been received, that because of various distortion or pulse spreading, the strength of the signal might be low. So, and to such a level it is low that it might not be detected as a logic 1, though it is a logic 1, but in the presence of various phenomena, its strength has been decreased and may not be treated as a logic high. So, we have to first amplify the strength of the signal that has been received, which is done by the front end amplifier. Now, after this we are having a filter equalization circuit. Now, this filter equalization circuit will do the process called as reducing the effect of intersimple interference, as well as it will reshape the original signal. That means that the shape of the signal might have been changed because of the various distortions that is taking place. After this, we are having a final that the portion is sampling circuit as well as the decision circuit. The sampling circuit is used to sample the signal, right? And a decision circuit is used to decision circuit at the final portion is used to make a decision that whether the received bit should be treated as a 1 or should be treated as a 0. Now, this clock recovery is proper for the proper synchronizations. We have already discussed why we are using a clock, because we have to do some bit interpretations. So, the receiver must know where the bit boundaries are. This is something which is done by the help of this clock. So, this is all about this entire optical receiver. So, after discussing this entire optical photo receiver or entire optical receiver, next thing is that what are the different types of a noise which is involved in the optical receiver, which is involved in the detection portion of this optical receiver. So, in our next class we will discuss in detail about what are the different noise that will affect the strength of the original signal. So, thank you all. We will meet in our next lecture video.